Picture the sun swelling until it fills half the sky, turning familiar horizons into an ocean of fire. What would the solar system look like when our star swells into a red giant? Let's walk through it. 7 billion years from now, the sun will run out of fuel in its core and begin a dramatic transformation. It won't explode, it will bloat, grow cooler at its surface, and become a red giant. That change will remake the entire solar system. Some worlds will be destroyed, others radically transformed. Today we'll tour that future, planet by planet, so you can see what happens when the sun turns into a red giant. The sun's red giant phase: when the sun exhausts hydrogen in its core, it will expand to roughly 200 to 250 times its present size. Its outer layers will balloon outward as fusion shifts into shells around the core. Luminosity soars and the star becomes a swollen, unstable ball of boiling plasma. Massive convection cells churn across the surface. From nearby worlds, the sun will no longer be a bright disk. It will be a blazing, living ocean. Earth's fate: Mercury and Venus will be gone, either vaporized or engulfed. Earth's fate is less certain. As the sun loses mass, planetary orbits will drift outward, and Earth may move just far enough to escape being swallowed. But escaping the star's envelope won't mean life survives. Average surface temperatures could climb to around 1,200 degrees Celsius. Any atmosphere that remains will be stripped away, leaving a lifeless, scorched rock under a sky that's effectively black because there's no breathable atmosphere left to scatter light. Above you, the red giant sun would dominate the sky, filling a huge portion of the heavens with a roiling, superheated surface. Mars and the inner system: Mars won't be spared the makeover. At roughly 2.28 astronomical units from the swollen sun, Mars would see a star with an apparent diameter of about 85 degrees, nearly a quarter of the sky. Its thin atmosphere won't protect it. Surface temperatures could reach around 940 degrees Celsius, turning the landscape barren and flattened by intense heat. The horizon would glow orange, and parts of the sun's corona, the hot, diffuse outer atmosphere, would be visible even from the surface. Jupiter and its moons move out to Jupiter's system and the view shifts. From the surface of Ganymede, Jupiter would hang as a shaded silhouette against a wildly bright sky. The red giant sun would sit low on the horizon, an immense sphere of violent plasma, throwing strange, eerie light onto the icy landscape. Around the sun, a vast corona would stream out in giant tendrils sculpted by powerful magnetic fields, stretching hundreds of millions of kilometers. Saturn, Titan, and a new habitable zone, Saturn's ring system, would likely be long gone by then, stripped away or dissipated, leaving the planet a naked gas giant. But there's a twist. The sun's rising luminosity pushes the habitable zone outward. Worlds that are now frozen could warm up. Titan is a perfect example. It has a thick nitrogen-methane atmosphere that can filter and redistribute heat, and during the red giant phase Titan could warm to about 0 degrees Celsius. In that window, surface ice melts and Titan could briefly become a true water world, with liquid water cooling on its surface. The atmosphere helps moderate temperature swings, at least for a while, allowing rivers and seas to appear where only ice exists today. Uranus and its icy moons. Uranus will migrate outward to roughly 28.8 AU, but despite that increased distance it will still receive a vastly larger amount of solar energy, over 100,000% more than today. Icy moons like Ariel face catastrophic change. Their icy crusts would melt, water and ammonia vaporize, and the resulting atmosphere could escape rapidly in a hydrodynamic outflow. What's left after the superheated onslaught is likely a desiccated, airless, rocky body, a reminder that warming doesn't always equal habitability. Neptune and Nereid. Neptune's system will also feel the effects. Neptune may sit around 45 astronomical units from the red giant sun. For an eccentric moon like Nereid, that means a strange but not entirely hostile change. Estimated equilibrium temperatures could rise enough to reach about 23 degrees Celsius at times, as the sun becomes some 190 times brighter in the sky. But Nereid's low gravity can't hold onto a thick atmosphere long term, so while temperatures might be mild briefly, the moon would remain effectively airless. Pluto and temporary atmospheres. Pluto will be much closer in relative terms, around 59.1 AU. But the red giant sun makes a hugely bigger difference than raw distance suggests. Ice on the surface, nitrogen, methane, carbon monoxide, would sublimate, forming a dense, temporary atmosphere. For a few million years, this could create one of the most Earth-like conditions in the outer solar system, at least by temperature and pressure. That atmosphere would be short-lived. Powerful stellar winds and the sun's intense activity would eventually strip gases away, returning Pluto to a frozen, thin state. Kuiper Belt worlds. Makemake Eris also changed dramatically. Makemake, migrating outward to about 68.5 astronomical units, would warm to roughly 173 degrees Celsius, still cold by human standards, but far warmer than today, and warm enough near perihelion to vaporize some volatiles. Eris, pushed to around 101.3 astronomical units but still warmed by the red giant's luminosity, could receive about 1.2 times the solar energy Earth gets today at perihelion. That would allow transient atmospheres and seasonal collapses of gases back onto the surface as frost at aphelion. Ejection and interstellar drift over the course of this violent transformation, orbital dynamics change. Some dwarf planets and small bodies may be nudged into new paths, and a few could be ejected into interstellar space when the sun finally loses enough mass or during later dynamical instabilities. By then, the sun will be on its way to becoming a white dwarf, a compact, cooling remnant surrounded by the debris and ghosts of planets that survived, shifted, or were lost. A view from afar. The Milky Way merger on much larger timescales. The sun and its neighborhood won't necessarily sit where they are now. Astronomers predict the Milky Way and Andromeda will merge in a few billion years, reshaping the galaxy. Some planets formed around other stars in that new, merged galaxy could host life and, if advanced civilizations ever look back, they might see a red giant sun as a bright, reddened star in their sky, visible even in daylight from a few light-years away. The chance for life elsewhere and human futures. All of this raises a hopeful question. If humanity, or its descendants, develop the technology to travel to distant worlds, could we stand on those new habitable planets and look back at the old solar system? It's conceivable. Planets warmed into habitable conditions during the red giant phase could host liquid water for a few million years. Enough time, in principle, for microbial life to thrive or for transplanted life to persist. But those windows are short and unstable compared to the billions of years life enjoyed on Earth. Summary: the red giant sun will be beautiful and terrifying. It will remake the solar system, inner worlds destroyed, mid-distance worlds baked or transformed, and distant worlds briefly warmed into surprising new states. Most changes are irreversible on human timescales, and many environments that become temperate will still be hostile in other ways: low gravity, thin or transient atmospheres, and intense stellar winds. Takeaway: the long-term future of our solar system is a complex mix of destruction and opportunity. The sun's red giant phase will end life on Earth as we know it, but it will also briefly create new, alien habitable zones where none existed before.
If you enjoyed this video, please like, subscribe to Palsa Lab and turn on notifications so you don't miss our latest uploads. At Palsa Lab, we explore space, science, astronomy, AI, and emerging tech, bringing clear explanations and fascinating discoveries. Have a question or idea? Drop it in the comments. Stay curious, keep exploring, and thanks for watching. See you next time.